Hello guys. If you're new here, thank you for stopping by. So I saw this question in a platform. I said we should just solve it and see. So the question says in the given circuit, find the current in ammeter. So we have this circuit. We have to find the current given the voltage in the entire circuit is 10 volt. So we have to calculate the current. So what is the approach? The first approach is to identify the resistors that are in parallel arrangement, right? So when you are done with that, you find the effective resistance, then you make use of Ohm's law to get your the value of the current. So let's start with it. Identify your arrangement. How do we identify parallel arrangement and series arrangement? When the resistors are arranged side by side, like this one and this one, so we can say they are in parallel. But when the resistors are in line, like if I have something like this, so they are in series. So if I have something like this, another one like this, so we can say they are in parallel. So from that, you can tell that this particular resistors, let's name it. Let's start the naming from here. Call this one R1. Okay. Can call this one R2. Can call this R3. And here is R4. And this one R5. Then R6. So can name it anyhow you like. So you can see that R2 and R3, they are in parallel arrangement. So this particular one here, they are in parallel arrangement. This one. So what do? We find the total resistance offered by these two. So we can call that R2, 3. So that's what we're going to find here. So when resistors are in parallel, what is the formula? If you remember this formula, 1 over R effective is equal to 1 over R1 plus 1 over R2 plus 1 plus 1 over R3 plus, right, until 1 over Rn, as the case may be. So that is parallel arrangement. So in series, it's just a algebraic summation of the two resistors, or the resistance, as the case may be. Okay. So in that case here, we can now say 1 all over R2, 3 is equal to 1 over R1, R2, right, plus 1 over R3, right? So that will give us, this implies 1 over R2, 3 is equal to 1 over R2 is 10 plus R3 is also 10. So which implies we are going to have 1 over R2, 3 equal to LCM is 10. That would be what? 10 in 10 is 1. 1 times 1 gives us 1 plus 10 in 10, 1 times this one gives us 1. That will give us 2 all over 10. So if I have 2 over 10, it means that if I take reciprocal, 1 over R2, 3 is equal to 2 over 10. Can take reciprocal or you just cross multiply, isn't it? So this implies we have 2 R2, 3 equal to 1 times 10 gives us 10. So which implies our R2, 3 is equal to 10 divided by 2, which is 5 ohms. So I've gotten for these two resistors. Now, if you look at R4 and R5, they are the same and the same arrangement. They are also in parallel. So I can say that R4 and R5 here also, R4 and R5 have the same value. So R4, 5, R4, 5, to find it, just the same thing. 1 all over R4, 5 will be equal to 1 over R4 plus 1 over R5. Is that correct? And they have the same value. So when you have two resistors like this, you can just write it as this implies that R4, 5 is equal to R4 multiplied by R5 all over R4 plus R5. So in that case, you're going to have, since they are both 10, 10, remember they have the same value, 10, 10. So I'm going to have 10 multiplied by 10 all over 10 plus 10. That will give us 100 all over 20. So 100 over 20, that is 100 over 20 is what? Sorry, let me clean this. So 100 over 20 is 5 ohms. So R4, 5 is equal to 5 ohms as well. So I have gotten this. I have gotten this. Now let me rewrite or redraw the circuit. Let us redraw the circuit here. Since I've combined this one to be single, our circuit now becomes something like this. So I have this here become my R2, 3, R2, 3. Then the next one here become my R3, 4. Is that correct? And the above that is another resistor, which is I term that one as R1. Then below that, I have another one, which is a R6, and connected to 10 volts. 10 volts. So this is my new circuit. So from this new circuit, you can see that these particular ones, they are in series. Just like what I've just told you here. They are in series. So R2, 3 and R3, 4 are in series. So in this case, let us say that let R be equal to R2, 3 be the effective, let R be the effective resistance of R2, 3 and R3, 4. I hope I'm correct. Oh, this is 4, 5. This is 4, 5. That is 4, 5. Is that correct? Yes. So let R be the effective resistance of R2, 3 and R4, 5. So in that case, since they are in series, so R will now be equal to R2, 3 plus R4, 5, as simple as this. So that will be equal to, this implies that R is now equal to 5, right? 5 ohms plus 5 ohms, which will give us a 10 ohms. Are we clear? So in that case, our circuit will now look like this. The whole of this become R, which has a value of 10 ohms, right? And there's another upper one, which is our R1 with a value of 5 ohms. The one below, which is R6 with a value of 5 ohms as well. So we have something like this. Yes, something like this. Then all connected to 10 ohms. All connected to 10 ohms. So I have 10 volt rather. So you can see now, in this case, the whole of these resistors, can you tell me, are they in series or in parallel? They are all in series. Now, R1, R, R6 are in parallel. They are all arranged side by side. The current that flow from this battery On getting to this point, path will go like this, path will go like this, path will go like that. Is how you identify parallel arrangement, right? Same voltage, different current. So since they are in parallel, you can find the effective resistance by using the formula 1 over R. This time around, I'll use effective equal to 1 all over R1 plus 1 over R plus 1 all over R6. So I have 1 over R effective equal to 1 all over 5 plus 1 all over 10 plus 1 all over 5. So here, what is LCM? 10. 5 in 10, 2 times. 2 times 1, that will give us 2. Plus 10 in 10, 1. 1 times 1, that will give us 1. Plus 5 in 10, 2. 2 times this give us a 2. So from here, I have 1 over R effective equal to 5 all over 10. This implies by the time I take reciprocal, R effective, right, is equal to 10 all over what? 5, which will give us a 2 ohms. So this implies that the effective resistance in the whole circuit, this whole circuit, the effective resistance of all these resistors is 2 ohms. Are we together? So it's 2 ohms. So when you get that, I can rewrite my final formula, a final circuit to be like this, as simple as this. So we have this. Here is our R, right? R effective. And here is the volt, 10 volt. So we are looking for the current I in the circuit. So the value of this one is what? 2 ohms. So here, using Ohm's law, we have that V is equal to IR, where I is equal to V all over R. So what is our V? That is 10. What is our R? That is 2, which will give us a 5 amp. So the current that flows through the circuit is 5 amps. So I hope you have learned something. So thank you for your time. See you in the next class.